So we have learned about empty sets, right? Next we are going to learn about equal sets. So what do you mean by an equal set? Or when do we say two things are equal or two quantities are equal? We will be saying if they are having similar shape and size, then they will be equal. Similarly, in this set, when two sets are equal, they will be having same number of elements and that elements will be equal. Okay. As we see for two objects, when we say two objects or two quantities are equal, we say shapes and size will be similar. So, in sets, we say if the number of elements in those two sets are equal and they coincide with each other, we can say the sets the sets are equal. Okay. So, two sets A and B are said to be equal if they have exactly the same elements. They have exactly the same elements and we write A is equal to B. Otherwise, the sets are said to be unequal and we can write A not equal to B. If they are equal, we write A equal to B, and if they are unequal, we write A not equal to B. So, this is the notation. Then let A equal to 1, 2, 3, 4 and B is equal to 3, 1, 4, 2. Then A is equal to B. Okay, because 1, 2, 3, 4 is same as 1, 2, 3, 4. Okay. So, they are having same elements and they coincide. Equal means they are exactly the same. They should be exactly the same, then only they will be equal. Let A be the set of prime numbers less than 6 and P be the set of prime factors of 30. Okay. So, A is the set of prime numbers less than 6. So, which are the prime numbers less than 6? 2 and 3. 2, 3, 5. Less than 6 means 6 will not be included. Then P be the set of prime factors of 30. Which are the prime factors of 30? 2, 3, 5. Okay, so we can say A and P are equal since 2, 3 and 5 are the only prime factors of 30 and which are prime numbers less than 6. Then a set does not change if one or more elements of the set are repeated. Okay, so we have learned that in a set we should not repeat the elements. So if an element is repeated, this is same as A. So 2, 1, 3 are the elements in our set B and our A is also having 3 elements 1, 2, 3. Then next is an example. You have to give reason. You have to check which all sets are equal and then you have to give reasons. So first of all, they have given this in the set builder form. We can write it in the roster form, then we can find the answer easily. A means set 0. And one more thing, this set 0 is not same as our null set or phi. This is not equal to phi because set 0 is having one element. Null set is not having any elements. So, set 0 and null set are not equal. Then set B. What is set B? X such that x greater than 15 and x less than 5. See, x is greater than 15 and x is less than 5. How is that possible? So, this will be a null set. Then C equal to x such that x minus 5 is equal to 0. So, C will be having only 5, right? Because x is a solution of this equation and x equal to 5. Then D. D means x square is equal to 25. So, you will be having 5 and minus 5. Then E. What is E? E is equal to, x is an integral positive root of the equation, x square minus 2x minus 15 equal to 0. Okay. So, the roots will be minus 5 and 3. Minus 5 and 3 are the roots of this equation. So, you can find the roots of that equation. Okay. So, now you can check which all are equal. Find the pairs of equal sets if any. There are no equal sets, right? Because A is set 0, B is 5, C is 5, then D is x square equal to 5 comma 5, E means minus 5 3. So there are no equal sets because all the sets are different. Then which of the following pairs of sets are equal? Justify your answer. Yeah, first one. If I am writing the first one, X means the set of letters in the word alloy. That means A, L, O, Y. Then next one, B means the set of letters in the word loyal. That is also L, O, Y, A. Yeah, as you can see, A, L, O, Y is same as L, O, Y, A. And the sets are equal. So you get X equal to B. Then second one, A equal to n such that n belongs to Z and n square less than or equal to 4. Okay. So I can write A as n square less than 4, n belongs to Z and n square less than 4. So which are the numbers? 2, minus 2, 0, 1, minus 1. Then B equal to x such that x belongs to R and x square minus 3x plus 2 equal to 0. So the solutions will be minus 1 and minus 2. So minus 1, minus 2. See, these two sets are not equal. This is set B. So here we get A not equal to B. Okay. So these are the cases. Then which of the following are examples of the null set? See, you can check. You can write the roster form. That's easier. So first I am writing the roster form of this set. Set of odd natural numbers divisible by 2. So which are the odd natural numbers divisible by 2? Odd natural numbers divisible by 2 means 0 is divisible by 2. No, but 0 is not a natural number, so we cannot take 0 is not divisible by any number. Okay. Then set of odd natural numbers divisible by 2 means 1 is there and 2 is there. But 2 is not odd, 2 is even. So there is only 1. So that is the only odd natural number divisible by 2. Then set of even prime numbers. So the only even prime number is 2. Then x is a natural number, x less than 5 and x greater than 7. That's not possible. So we can say this is 5. Then fourth one, y such that y is a point common to any two parallel lines. Yes, how can it be possible? This is 5, right? Because if you consider two parallel lines itself means they doesn't intersect. So if they doesn't intersect, there will be no common points to them. So you can say y is a point common to any parallel line means that is a that statement itself is wrong. So you can say that is 5. So this 3 and 4 are the null set. Which of the following are finite or infinite? The set of months of an year, 12 months, so finite. Then 1, 2, 3, etc. This is infinite, right? Because this is continuing infinitely. Then 1, 2, 3, etc. 99 up to 100. So these are having, this set consists of 100 elements because this 1, 2, 3, then it continues up to 99, then 100. So you can say from this is having 100 elements and it's finite. The set of positive integers greater than 100. Okay, the set of positive integers greater than 100 means there will be infinitely many numbers greater than 100. So you can say this is infinite, right? Because after 100 you can write any number of elements, or there are infinitely many positive integers greater than 100. Then the set of prime numbers less than 99. This is finite because from prime numbers less than 99 means what? The set of prime numbers less than 99 means it's finite. Then state whether each of the following sets is finite or infinite. The set of lines which are parallel to the x-axis, this is infinite. Because if you draw our x-axis, if I'm writing this as x and y, you can find infinitely many lines, right? You can have infinitely many lines parallel to x-axis. So this is infinite. Then the set of letters in the English alphabets, it means 26 letters are there, and you can say it's finite. Then the set of numbers which are multiple of 5. So with you can have infinitely many multiples of 5, right? So this is infinite. Then the set of animals living on the earth. See, is this set finite? Because biologically there are many species or many living organisms that we haven't found yet according to studies. So you cannot say the set of elements living, a set of animals living on the set on our earth is finite, because I mean in Amazon forest and all there are different species that have not been discovered yet. So we can say this is infinite. Then the set of circles passing through the origin 0, 0. How many circles will be there? I'm drawing the origin. This is my origin. So I can draw infinitely many circles, right? So I can say the set of circles, see, the figure is not like this, I'm sorry. The set of circles passing through the origin 0. So this will be like this, 0, 0, 0. These are all circles passing through origin. Okay, this is how we draw. So you can find infinitely many circles passing through our origin, and this is also infinite. Then in the following, state whether A equal to B or not. A, B, C, D, B, C, B, A. So A equal to B. First question, A equal to B. Second one, 4, 8, 12, 16. 4, 8, no. A is not equal to B. Why A is not equal to B? Because in A, 4, 8, 12, 16 is there. Here 12 is not there. Okay, B does not have 12, and hence A is not equal to B. Then A, 2, 4, 6, 8, 10. Positive even integer and x is less than or equal to 10. Yes, these two sets are equal. So which are the positive even integers less than or equal to 10? Positive even integers means 2, 4, 6, 8, 10. Okay. So we get A is equal to B. A equal to B. Then fourth one, A equal to x such that x is a multiple of 10. Multiple of 10 means 10, 20, 30, 40, etc. Then B means 10, 15, 20, 25, 30, etc. So 15 is not a multiple of 10, right? So we can say A not equal to B. Next one, are the following pairs of sets equal? Give reasons. Are they equal? A equal to 2, 3. B is equal to, I am going to write the roster form. A means 2, 3. Then B, x such that x is solution of x square plus 5x plus 2 and 3. 2 and 3 are the solutions. Then C, x such that x is a letter in the word follow. So F, O, L, W. Then B, A, B, C. I think this is D. This is our set D. This is set D, and A, B, this is our set C. Okay, so D will be Y such that Y is a letter in the word wolf. So this is also F, O, L, W. So you can say A equal to B, and I am sorry, this is our second question, right? So our first question will be A and B, and A is equal to B, and second question C is equal to D. but A and C are not equal and B and C are not equal. Okay, so in first question we get A is equal to B, and in our second question also we get A is equal to B. Okay. Then from the sets given below, select equal sets. Yes. Is there any set equal to A? 2, 4, 8, 12. 2, 4, 8, 12 is not there. So we can choose B. 1, 2, 3, 4 is there? Yes, 1, 2, 3, 4 is there. So you can write B equal to D. Then C, 4, 8, 12, 14. 4, 8, 12, 14 is not there. Then minus 1, 1. Minus 1, 1 is there. E and G are equal. 0, A is not there, 0, 1 is not there. So these are the equal sets. B and D are equal and E and G are equal. So next we are going to learn about subset. And what do you mean by subset? We have learned about sets, right? And subset means it's a part of set, or we'll be choosing some elements from a set and making it a subset. So we'll be learning about this in more detail. And first of all, definition. A set is said to be a subset of a set B if every element of A is also an element of B. Okay, so how can you define a subset? You are given A and B, and A is said to be a subset of B if every element of A belongs to B. Okay, then A will be subset of B. Technically speaking, if we are writing a set and taking some elements out of it and writing another set, it will be a subset. Or we can choose all the elements from a previous set, or else we can choose no elements from that set. All these are subsets. See, in other words, A subset of B. This is the notation, subset notation. If whenever A belongs to A, then A should belongs to B. That is, if we choose, if A is subset of B, and we choose a small letter A from capital A, or we are choosing an element small letter A from this capital A, then we get A belongs to B. If A is subset of B, then you get this thing. Then A subset of B, if A belongs to A, implies A belongs to B. That's it. That is the definition. Now, we read the above statements as A is subset of B. A subset of B if A is an element of A. This symbol is used for element symbol, means element of or belongs to, and this is subset of. Okay, so if we put a small dash in between subset of symbol, you get belongs to symbol. Then it follows from the above definition that every set A is a subset of itself. That is what I said. See, you can choose all the elements from a previous set and write it down. Then it will be A subset of A. And we can say every set is a subset of itself. But it's an improper subset because we are choosing all the elements. Okay. Since the empty set phi has no elements, we agree to say that phi is also a subset. So there are two subsets for every set. Phi is a subset of every set and A is a subset of itself. So if you are given two sets and you are asked to write two subsets, you can write the set itself and phi. So some examples are given. The set Q of rational numbers is a subset of the set of real numbers. Okay. So the real numbers includes rational numbers and irrational numbers. So here they have said Q is a subset of R. In the first question or in the first example, it said that Q is a subset of R. That is, rational numbers are subset of real numbers. Then if A is a subset of all, A is the set of all divisors of 56 and B is a set of all prime divisors of 56, then B is a subset of A. Okay, so if we are writing the divisors of 56 and we are choosing some prime divisors, we are choosing the prime numbers from that, then our second set will be the subset of the previous set, that is B subset of A. Then A is equal to 135 and B is X is an odd natural number less than 6. So the odd natural numbers less than 6 means 1, 3, 5. So A is equal to B. Okay. So we can say if two sets are equal, then they are subsets of each other. If A is equal to B, A is subset of B and B is subset of A. Then in fourth one, A is equal to A, E, I, O, U, the set of vowels, and B is equal to A, B, C, D. Then A is not a subset of B. Also B is not a subset of A. Why? Because as you can see, this A is having set U, element U. U belongs to A, but U does not belongs to B. So A not subset of B. So we can write it like this. This are not a subset of B. Then let A and B be two sets. If A is subset of B and A not equal to B, then A is called a proper subset. Okay. So if our subset is not the set itself or our phi, then we can say it's proper subset. If we are writing the subset and it is a set itself, then it is our improper subset. Okay. Then A is called a proper subset. So what do you mean by proper subset? Proper subset means that subset should not be phi and the set itself. All the subsets which are other than the set itself and phi. Then, so what will be improper subsets? Improper subset means the set itself or phi. And if we are writing A subset of B, then this A is called subset and B is called superset. Okay. So for example, A is having 1, 2, 3 is a proper subset of B is equal to 1, 2, 3, 4. A is having 1, 2, 3 and B is having 1, 2, 3, 4. 1, 2, 3, 4. Okay. If a set A has only one element, we call it a singleton set. Now see, from this you can write A subset of B. Okay, because A is having 3 elements and B is having 4 elements and the 3 elements of B form our set A. Then, what do you mean by a singleton set? Singleton set means there will be a single element in that set. There will only be a single element. Thus, if you are writing set A, then it is a singleton set. Okay. Then, consider the sets phi. A is equal to 1, 3, then B is equal to 1, 5, 9, C equal to 1, 3, 5, 7, 9. Insert the symbol subset of or not subset of between each of the following pairs. Okay. So, you are given some sets and you have to find if they are subsets of each other. Okay, phi is subset of every set. So, you can write phi subset of B. Then A subset of B. A means 1, 3. B means 1, 5, 9. But see, 3 belongs to A and 3 does not belongs to B. So, this is not a subset. Then A subset of C. Yes, 1, 3, 5, 7, 9. So, A is subset of C. Then B is subset of C. 1, 5, 9. 1, 5, 9. Yes, subset. Okay, so this is how we check it's a subset or not. Okay. Next one, A is equal to A, E, I, O, U. B is equal to A, B, C, D. If A is a subset of B. Okay. So, our set A means A, E, I, O, U. And B means A, B, C, D. That's given. So, they are asking if A is subset of B. No, because U is not there or I is not there in B. Then E is not there, O is not there. All these 4 elements are not there in B. So, you can say A is not a subset of B. Then, is B a subset of A? No, because B, C, D is not there in A. So, B is not a subset of A. So, how do we give reason? We can write it like this. E, I, O, U belongs to A, but E, I, O, U does not belongs to B, this implies A is not a subset of B. Similarly, we can write B, C, D belongs to B, but B, C, D does not belongs to A. This implies B is not a subset of A. Okay, so this is how we give reason for such questions. Then let A, B and C be three sets. A belongs to B and B subset of C. Is it true that A subset of C? If not, give an example. Okay, it's a bit confusing, right? So while seeing this question, we think or we may think this is true, but this is not the case. See, A belongs to B and B is subset of C. If it was like this, A subset of B and B subset of C, this implies A subset of B. But these two things imply A subset of C or here C. Is this true? They are asking that A belongs to B and B subset of C, then A subset of C. Is it true? No, this is not true. So if you are saying something as false, you should give an example, then only our statement will be valid. So I am writing an A, I am writing 1, okay, and I am writing B as A belongs to B. So I am writing 1 and 2. Then C, B is a subset of C. Okay, so what is C? I am writing C as 1, 2, 4. Okay, so this is my C. So as you can see, A belongs to B, right? A belongs to B because minus 1 itself belongs to B, and B subset of C, B subset of C, correct, because all the elements of B is there in C. But A subset of C is A subset of C because A is not a subset of C. Why A is not a subset of C? Because 1 does not belongs to C. Okay, for A to be subset of C, you should have 1 here. If C was like C is equal to 1, 2, 4, 1, then we can say this A is belonging to C. But since our C is like this, since our C is set 1, 2, 4, we are not able to say A is a subset of C. Okay, so this is a counter example and I hope you understood this problem. Then subsets of set of real numbers. So what are the subsets of set of real numbers? See, the set of natural numbers means we have learned this one. These are our natural numbers, then these are our integers, then these are our rational numbers. So they have written the set builder form here. Okay, so we can read it like this. Q is the set of all numbers x such that x equals the quotient p by q, where p and q are integers and q is not 0. So where q and integers, p and q are integers and q not equal to 0. This is the definition of rational numbers. So they have written it in the set builder form. Now members of Q include minus 1, etc. Minus 1, 5 by 7, 3, 1 by 2, etc. These are all elements of Q. Then the set of irrational numbers. An irrational number is denoted by T. Irrational number denoted by T, and it is composed of all other real numbers. Thus T is equal to, what is T? Set of all x such that x belongs to R and x does not belongs to Q. As we said, our definition, irrational numbers are those irrational numbers are those real numbers which are not rational. Okay, so you have to write it like this: set of all x such that x belongs to R and x does not belongs to Q. That is all real numbers that are not rational. Then members of T include root 2, root 5, pi. Okay, we have learned our irrational numbers are root 2, root 5, pi. All these are examples of irrational numbers. Then some of the obvious relations among these subsets are, you have to know this one. See, natural numbers will always be a subset of whole numbers, and whole numbers will always be subset of integers. Integers will be a subset of rational numbers, and rational numbers will be subset of real numbers. Also, our irrational numbers will be subset of real numbers. Okay, then n not subset of T. Natural numbers are not irrational numbers. Natural numbers are rational numbers, and irrational numbers means those real numbers which are not rational. Okay, so these are all obvious implications. Okay, then intervals are subsets of R. So do you understand this one? I have written, see, this is AB, curly brackets A comma B. So this means if you are considering A and B, you have to take all those things in between A and B other than A and B. You should not include A and B here if you are using open brackets. So to say that or to represent that, they use this notation. If they have given a circle here which is not darkened, then we can understand, we should be able to understand that that is open bracket, or A and B is not included. Okay, and if A and B are darkened, then we can say A and B are included in that interval. So you have to consider A and B, and it is also represented by R square bracket. Okay, so here in this A is included and B is not included. So for A they have given square bracket, and for B open bracket. Here B is included, so B is having square bracket, and A is not included, so A is having open bracket. Okay, so this is a notation you will be seeing throughout this textbook. So I hope you understood this one. Then here we note that an interval contains infinitely many points. Okay, an interval contains infinitely many points. So what do you mean by an interval? What do you mean by interval? Here we saw this one, A comma B. These are all intervals. I have drawn this figure. This figure means I am considering a number line, real number line. So I am considering 0 and 1. And all those numbers in between 0 and 1. How many numbers will be there in between 0 and 1? There will be infinitely many numbers, right? I can find 0.1, 0.001, 0.002, etc. How many numbers? We cannot count. So there are uncountable numbers in between 0 and 1. Okay. So while writing the interval, or we are taking whatever interval we choose, we get infinitely many number of elements in that interval. Okay, so that is what they said here. Then for example, set of all x such that x belongs to R minus 5 less than x less than or equal to 7. Okay, see, a set builder form is given, x such that x belongs to R and minus 5 less than x less than, this is a set. Okay, so this means this is an open, means half open interval. Half open means it's open on one side but it's closed on the other side, because they have included 7. Equal to symbol is there, which means 7 is included, and we should put square bracket for that. Okay, so this is minus 5, 7. This is our interval, and this is written in the set builder form, and then I wrote it like this, minus 5, 7. and the interval minus 3, 5 can be written as, minus 3, 5 can be written as set of all x such that x belongs to R, then minus 3 less than or equal to x less than 5. Okay, so this is how we write minus 3, 5. This is minus 3, 5. Then, what do you mean by the length of an interval? What do you mean by the length of an interval? If you are given two intervals, so we have learned about closed interval. See, this is closed interval, then, sorry, this is open interval. I'm really sorry, that's open interval. This is closed interval, and these two are half open interval, half open, because this is open only in one side. Okay, so these are half open interval. Then, what do you mean by the length of an interval? Length means you should subtract our first element from the second element, that is b minus a. If you are given with an interval ab, then the length of the interval will be b minus a. Simple. Now, what do you mean by a universal set? So, we have learned about empty set, equal sets, then we have learned about subsets. So, now is universal set. So, what is a universal set? Okay, so in our context, as our context changes, universal set also changes. Okay, so if we are dealing with our real numbers, and we are studying about our natural numbers, irrational numbers, or rational numbers, etc., then our universal set will be real numbers. So, if you are given a question, in that you will be given a universal set. Universal set means that set includes all the other sets, or all the other sets are formed from this universal set. Okay. So, first of all, you have to check the context and you have to make the universal set, or to write the universal set. And the main property of the universal set is universal set must contain all the other elements. Means you should consider all the sets all together, and all the elements of each one of these sets should be included in our universal set. Okay. Then universal set means, for example, I have said about R. R is real numbers, set of real numbers. So, if I am writing real numbers, this is our universal set. And if we choose N, Q, T, etc., natural numbers, rational numbers, irrational numbers, all these can be written from our real numbers, or all these are included in our universal set, that is real number, set of real numbers. Okay. Then, make correct statements by filling the symbols, subset of or does not or not subset of in this. 2, 3, 4. 2, 3, 4 is included here. 2, 3, 4 is here. So, you can write subset of A, B, C. A, B, C. A is not here, right? A is not here. So, this is not a subset. Then X such that X is a student of class 11th of your school. Then X is a student of your school. Okay. So, this is our superset. All the students of the school is considered, and it is a superset. Then students of only 11th standard is taken, and it will obviously be a subset. Then X such that X is a circle in the plane, X such that circle in the same plane with radius 1 unit. Okay. See, you have considered all the circles in a plane, and you can say their radius varies. Their radius can be 1, 2, or whatever it may be. The radius may be different. Radius are different. So, we can say the radius of 1 unit is the subset of circle in the plane, set of circles in the plane. Okay. So, since it is this one is the subset of this one, you can write it like this also, because they asked us to fill with symbols subset of or not subset of. So, you can write it like this one, because our first set is not the subset of the second one. Okay. Then X such that X is a triangle in a plane then x such that x is a rectangle in the plane. And this is obviously not a subset because triangles are never rectangles. Okay, then x is an equilateral triangle in a plane, x is a triangle in the same plane. Yes, they are subsets because equilateral triangle means that is a type of triangle. So if you are considering this set of all triangles, then equilateral triangles means it is also a type of triangle, or it is also a triangle. So this is a subset. Then x such that x is an even natural number, x is an integer. So this is also a subset because even natural number is the subset of integers, or all natural numbers itself are integers, and if you are considering even natural numbers, that is also subset of our integers. Then examine whether the following statements are true or false. Okay, so our first statement is a comma b not a subset of b c a. Okay, so is that true? Because a and b is there in this one, right? So this is a subset of, so the statement is false, right? This is false. Then a comma e subset of x such that x is a vowel in the English alphabet. Yes, this is true because this is a e I o u. A e is a subset of a e I o u. Okay, then 1 2 3 subset of 1 3 5. This is false because 1 2 3 is there and 2 is not there in the set. So this is false. Next, set A subset of A B C. Yes, this is true because A is there, A is only there in our first set, and second set contains A B C. Then second set, set A belongs to A B C. Is that true? See, you should write subset of because A is there in this set. For writing belongs to, the set A must itself be there in this set. But here the element A is only there. Set A is not there as an element. So this is false. Okay, you can only write as subset of, not belongs to. Then x such that x is an even natural number less than 6. Subset of x such that x is a natural number which divides 36. Okay, so x is an even natural number less than 6. So what are the even natural numbers that are less than 6? 2, 4, I think 2 and 4 itself. 2, 4, 6 means 6 is not less than 6. So we cannot write 6. 2 and 4 are the even natural numbers less than 6. Then x such that x is a natural number which divides 36. So which are the natural numbers which divides 36? Yeah, 2, 4, 6, etc. 6, 36, 1 and all. So obviously we can say they are subset because 2 and 4 is there in our second set. So this is true. Okay. Then let A is equal to 1, 2, 3, 4, 5. Which of the following statements are incorrect and why? So you have to check which of the following statements are incorrect. So 3, 4 subset of A. Is this true? No, because this 3, 4 is not there as elements. Okay, 3, 4 subset of A means you should be able to, yeah, this is a subset. This is a subset of A. This is true. But 3, 4 is just an element. So 3, 4 belongs to A is true. So this is incorrect. Then this is a subset of A. This is true. Correct. Then 1 belongs to A. Correct. So the only statement which is false is 3, 4 subset of A. Okay. So if we are writing 3, 4 subset of A, either you should write it like this or 3, 4 belongs to A. Okay. So either like this or this. This or the first statement is true. The first statement is false anyways. Then 1 subset of A. 1 subset of A is false, right? Because 1 belongs to A. Then 1, 2, 5 subset of A. 1, 2, 5 subset of A is true. Then 1, 2, 5 belongs to A. This is false because 1, 2, 5 are subsets. That is correct. And for writing like this, or for writing like belongs to, you should get set 1 to 5 as an element in our set A. But our set A does not have an element like 1 to 5. Okay. So this is false. And 1, 2, 3 subset of A. This is also false, because 1, 2, 3 is means 3 is not an element. You have only set 3, 4. You don't have 3 as an element there. So you can say this is also false. Then 5 belongs to A. This is false, because 5 is a set, right? 5 is set. 5 means we have learned it's an empty set. So you should write only subset of. So this is true. Subset is true. This belongs to notation is false. Then set 5 subset of A. This is false, because for writing like this, you should have a set 5 in our set. Okay, or you should have an element 5 in this one. If you have an element 5 in our set A, then only you can write set 5 belongs to, or set 5 subset of A. So since there is no element like 5 in our universal set, you can write it as false. Okay. Then write down all the subsets of the following set. So first one is set A, and the subsets will be, this is a singleton set. What was singleton set? Singleton set means there is only one element. Okay. So the subsets are, the set itself and 5. These two subsets will always be there. Whatever whatever sets you choose, A and 5, or the set itself and 5 will be there. Then 2, A, B. So what are the subsets? The subsets will be, first one is singleton A, singleton B, then the sets itself, then 5. Okay. So these are our subsets. Then 1, 2, 3. 1, 2, 3 means which all will be? Set 1 will be there, set 2 will be there, set 3 will be there, then 1, 2, 2, 3, then 1, 3, then 1, 2, 3 and 5. So first, while writing the subsets, you have to write the set itself 5, and then you have to write singleton sets, then pairs, then you have to take it as triples and so on. Okay, since you have only 3 elements, you need not take it triples. You have to write it only like 1, 2, 3. You don't have to write it 2, 3, 1 or 3, 1, 2, etc. Okay, so you have to write this only once. Then 5. The only subset of 5 is 5 itself. There is no other subsets for 5. Okay. Then write the following as intervals. You want to write it like intervals. So for writing like that, see here there is less than symbol. So less than symbol means this is open bracket, and here less than or equal to, so closed bracket. Okay. Closed bracket means our square bracket, open bracket means rounded bracket. Then here both is less than or equal to, means less than. So this is minus 12 and minus 10. Okay. Then 0 less than or equal to x less than 7. So this means 0, 7. Okay. This is 3, 4. Yes. Then write the following intervals in set builder form. So for writing it in the set builder form, you have to write set of all x such that x belongs to, or you can write minus 3 less than x less than 0. Second one is set of all x such that 6 less than or equal to x less than or equal to 12. Okay. Then third one, set of all x such that 6 less than x less than or equal to 12. Then fourth one, set of all x such that minus 23 less than or equal to x less than 5. Then what universal sets would you propose for each of the following? Yes, so we have learned about universal set. What was universal set? It was the main set from which we are writing the subsets and all. Okay, that was the meaning of universal set. So you have to write down the universal set from which this sets can be found. The set of right triangles and the set of isosceles triangles. Okay, so for both these sets we can take the universal set as the set of triangles. The set of triangles. So this is our universal set for these two sets. Then given the sets A is equal to 1, 3, 5, B is equal to 2, 4, 6 and C is equal to 0, 2, 4, 6, 8. Which of the following may be considered as universal sets for all the three sets A, B and C? Okay, so you are given three sets and you have to find the universal set. So as I said, while writing universal set, first of all you have to write down all the elements in our given sets. Okay, so you have 1, 3, 5. I wrote down 1, 3, 5. Then 2, 4, 6. 2, 4, 6. Then 0, 2, 4, 6. So you have to take 0. Then there is 8. 8 also. Okay, so anyway, these elements should be there in our universal set. So if I consider this set, this is not having 8. So this is not possible. 5 is not possible. And this is not having 0, so this is also not possible. This is our universal set. Okay. So while writing the universal set, first of all you have to write down those elements from all the sets and then you have to choose a bigger set, or that set itself will be the universal set. Okay. So next we are going to learn about a Venn diagram. So what is a Venn diagram? And it's a diagram, right? Venn diagram, it's a diagram. So why do you need a diagram? So we are learning about sets, and why do you need a diagram? To represent a set. Simple. Okay, so till now you have learned about graphs, bar graphs, then pie charts and different pictographic representations, right? So to represent a data we know different kinds of graphs and those kinds of things. Similarly, to represent a set, if a set is given, you need to represent it in a pictographic way. Okay, and why do we need to represent it in that way, or what is the need of a Venn diagram? That is simple. So if a set is given, or you are given with two sets and you are asked to find the common elements, you will take some time, right? But if it is in the form of a picture, you can check easily which are the common elements, or which are the elements which are taken outside, or the elements which are not there in our set, and all those things you can understand easily by using a Venn diagram. So that is the need for this diagram. And so okay, so let's check what is a Venn diagram. So generally a Venn diagram will be in this manner, where this will be A, this will be B, and this is our A common elements, common to both A and B. Okay, and we will be drawing our universal set like this. This will be our universal set. The square or this rectangle represents our universal set, and inside that we will be drawing our sets like this. So we can mark those elements which are exclusively there for A here, only there in A. These elements will be there only in A, and the elements which are there in B is drawn here or labeled here, and the elements common to A and B will be drawn or marked in this space. Okay, so we can easily understand which all are common or which are not there. All those things we can understand it easily. Then C. this is a figure. This is our universal set. The square or this rectangle represents our universal set. Inside that, A is there, or our set A is there. So if you are asked, this 1 is 1 in the set A. No, right? 1 does not belongs to A because 1 is outside. A means this circle. So next somebody asks if 6 is there. So you check, where is 6? 6 is inside A, right? So we can write 6 belongs to A. So this is the use of a Venn diagram. You can easily find out where is their number, or where does the number lie. Okay, a number, not only number, you can represent any kinds of things, any kinds of elements of sets. You can write all the elements of the set in the form of a Venn diagram. Okay. Then this one, you are given a universal set and a set A is there. Inside set A there is B. So B, this 4 and 6 is there in B, A and U. So this is actually B subset of A subset of our universal set. Okay. So the Venn diagram of this form is like this. Okay. Next, operations on set. Okay, what is an operation? And we have learned about addition, subtraction, multiplication, division, all those things in our lower classes, like in arithmetic. We have learned to add numbers, right? Similarly, we can operate sets. So that is not addition, or the name is not addition here. We will be using another terms. And these are the operations. Sets can be added or sets can be subtracted, and all those operations, which all are the operations that can be done on a set. And we are going to learn about those operations. So first one is union. What do you mean by union? Union means A union B. You will be given two sets. I am saying about two sets first of all. Two sets A and B are given. Okay. Then you can write A union B. This is the symbol for union. Union means you have to take the elements. Okay. Union, this is a symbol for union. You will be writing one big U. Big U. This is the symbol. So I am taking two sets. I am taking set A as A, B, C. I am taking set B as Ram, Sita, and this element A. So I am taking the union. How will I take union? Union means, first of all, you have to write those elements in A. That is A, B, C. Then you have to add those elements in B, or you have to write down the elements of B also. So that is Ram and Sita. Should I write this A again? No, because A is written there once. So this is A union B. So while taking union, if an element is repeated twice, you have to write it only once. So this is union. Next, a question is given. A equal to 2, 4, 6, 8. B means 6, 8, 10, 12. So you have to take union. What is A union B? A union B means you have to write elements of A. 2, 4, 6, 8. Then 2, 4, 6, 8 is written. Then 10, 12. Then you have to write elements of B also. So this is actually A union B means A or B. You have to take the elements of A and you have to take the elements of B. Okay, actually you have to take it means A or B. Then let A is equal to A, E, I, O, U and B is equal to A, I, U. Show that A union B is equal to A. So what is A? A is A, E, I, O, U. A, E, I, O, U. What is B? A, I, U. and you have to find A union B. A union B means you have to write all the elements A, E, I, O, U. Then A. A is there written. I means I is written. U is also written. So A union B is A, I, O, U. And this is same as A itself. So they have asked us to find A union B and A and prove that they are equal. As you can see, they are equal. Then let X equal to Ram, Geeta, Akbar. Okay, so X is having Ram, Geeta and Akbar. Then set of students of class 11th who are in a school hockey team. So hockey team students is X. Ram, Geeta and Akbar. Then Y means football team. Y. Geeta, David, Ashok. David and Ashok. So these are our two sets and they asked us to find A union B. So what is A union B? A union B means X union Y. So you have to write all the elements Ram, Geeta, Akbar, then Geeta is already written, then David and Ashok. David, Ashok. So this is what is known as X union Y. Okay. Then the union of two sets. This can be written like this, or the Venn diagram of A union B is like this. As I have said, this is our universal set and this is our set A, this is set B, and A union B means you have to write all the elements like A, then the elements which are common to A and B, then the elements in B. So this forms A union B. The portion which is shaded or the colors, the things given in blue color, this forms our union. And A union B means X belongs to A or X belongs to B. This is what I said. Okay, so union means A or B. Either it should belongs to A or it should belongs to B. If I choose an element from A union B, then either it should belongs to A or it should belong to B or it should belong to both. Okay. Then the union of two sets can be represented by a Venn diagram, and this is our Venn diagram. Okay, the shaded portion means the region which is in blue color. Okay. Then some properties of operations of union. Okay, so commutative law. Commutative law means A union B will be equal to B union A. This is commutative property. Next is associative property. So what was associative property? Yes, associative property means first of all you have to operate first two elements. Then you operate the third element. Similarly, if you operate the second and third element first and then you operate it with the first one, it is known as the associative property. So this union satisfies commutative property and associative property. Next, A union phi. A union phi means what? A union phi means you have to write down all those elements in A and the elements of phi. Phi is a null set, right? There are no elements in phi. So you should write the elements of A, or A union phi will be equal to phi. And this identity is known as law of identity element. Okay, law of identity element. And phi is known as the identity of union. Okay, phi is known as the identity of union. What do you mean by identity? See, if I am adding 1 plus 0, I get 1. So 0 is the identity of addition. Because while doing addition, if I add 0, I get the number itself. Similarly, if I take the union phi with any of the set, I get the answer as our set itself. So here the identity element will be phi. Then A union A is A, and this law is called idempotent law. A union A is equal to phi means this is known as idempotent law. Then U union A is equal to U, which means law of U. Okay, this is called law of U. U union A means you have to take the union of U and A. So you have to, first of all, you have to write the elements of U. Then while writing the elements of A is a subset of U, right? A is a subset of U. So you need not write the element of A again. So U union A will be U, and it is called law of union. So next operation is intersection. What is intersection? Intersection is opposite of taking union. Union means we will be taking all the elements. Intersection means we will be taking the common elements only. Okay, if you are given two sets and if you are asked to find the intersection of those sets, you have to take the common elements from both those sets. For example, if I choose A is equal to 1, 2 and B is equal to 2, 4, then A intersection B will be having, you have to take down the common elements. The common element is 2, right? So A intersection B will be having 2. Then consider the sets A and B of example 12. Okay, so our example 12 was having Geeta, Akbar, that right? No. Yeah, A and B means example 12. 2, 4, 6, 8, 6, 8, 10, 12. 2, 4, 6, 8 and 6, 8, 10, 12. 2, 4, 6, 8, then 6, 8, 10, 12. Okay, this is our set. And they asked us to find the intersection, or A intersection B means what? A intersection B. 6 and 8 is common. So you have to take 6, 8. This is A intersection B. Then consider the sets X and Y. Yeah, X was having Ram, Geeta and Akbar. And Y was Geeta, Ashok and David. This was our set. And they asked us to find intersection. So what is the intersection? Intersection of X and Y means you have to take the common element. The common element is Geeta. Okay. Then a set is given. Set A and B are given, and they asked us to find A intersection B. A intersection B means you have to take down the common elements. So what are the common elements? 2, 3, 5, 7, right? 2, 3, 5, 7. And B is also 2, 3, 5, 7. Hence we got A intersection B is equal to B. Then, yeah, this is the Venn diagram for intersection. Here, this is our universal set, and this is our first set A, this is our second set B, and intersection means you have to take the common elements only. So intersection means actually it's A and B. Okay, so this is X such that X belongs to A and X belongs to B. So apart from union, while taking intersection, you have to check those elements which are belonging to both A and B. Okay, that is the difference. So in union, you can take all the elements. It should either belongs to A or B, but here it should belongs to both A and B. Then, see, in this Venn diagram, you can see A and B are not having any common elements, or we can say they are disjoint. Okay, and if they are having no common elements, if two sets are given such that they are having no common elements, then we can say they are disjoint set. So here A and B are disjoint. Why do we say that? Because they have no elements in common. Okay, and an example is given here, 2468 and 1357. These are odd numbers and these are even numbers, and here A intersection B is equal to 5 because there are no common elements. And this is the Venn diagram for a disjoint set. Then some properties of operations of intersection. Yeah, we have learned the properties for union. So these are the properties for intersection. Intersection, first property is commutative law. Commutative law means A intersection B is equal to B intersection A. Next is associativity. As you know, operating the first two elements with the third element is same as operating the second and third elements with first element. So associative law is satisfied. Then law of phi and u. Okay, phi intersection A is phi because phi is having no common elements, and if you intersect it with A, then it will be phi. U intersection A is A because U and A has only the elements of A in common. Then idempotent law. Idempotent law means what? Idempotent law means A intersection A is A. Idempotent law is same in union. A union A is also A and A intersection A is also A. Then this is distributive law. That is, intersection distributes over union. So we have learned about what have we learned? We have learned about union, right? So we can distribute intersection over union. A intersection B union C means you can open the brackets, then it becomes A intersection B, A intersection B union A intersection C, union A intersection C. So this is a distributive property where intersection is distributed over union. Then, yeah, in this figure, the colored portion implies B union C. So B union C means you have to take all the elements in B and all the elements from C. So this is B union C, and this is A intersection B union C. A intersection means you have to take intersection with A. If you take intersection with A means those elements common to A and B union C. So A and B union C are having only these elements in common. Okay, so this is A intersection B union C. Then this is A intersection B. A intersection B means, yes, A and B. A and B. A and B means, yeah, these are the common elements. Then A and C. A and C means these are the common elements. So if you take the union, you will get the same as, yeah, A intersection B union A intersection C. So this was the Venn diagram for distributive property. Distributive property can be proved by using our Venn diagram. Okay.